drive down the street and it doesn't matter.
The hill never goes down.
Guys. It's chemistry hour. I'm Veronica.
I'm Bridget.
I'm Haven.
I'm Chris.
And you're watching Disney Channel.
Well, at first we were really overcomplicating things.
As usual.
Yeah, we tried to do something on acid rain. We had discussed collecting samples of like creek water and looking at their pesticide levels. And then Miss Strout basically gave us a big fat no, because we were overcomplicating things. So V, the brilliant V, told us that, hey, you can titrate vinegar. And they were like, oh yes we can, and our households already have vinegar. Ta-da! The question we asked for a research question is, what is the amount of NaOH needed to titrate, and thus the concentration of acetic acid, in different types of vinegar? This question is formed around the basis of needing to gather knowledge of what the chemical composition of vinegar is, and where it may classify as an acid, acetic acid. This also involved research to note the effects of diluting of vinegar, specifically pertaining to those that to the 3 vinegars that were diluted with distilled water, so that proper titration could occur. In efforts to collect background research to form a hypothesis, the topic of vinegar was used for cleaning as researched. These proposed ideas are the types of vinegars used for cleaning and killing bacteria, which tended to be grain-based, whereas other types of vinegar that would support probiotic growth and were safe for ingestion tended to be fruit and produce-based.
The hypothesis was, if the type of vinegar used has a lesser fruit content, then the molar concentration of the acetic acid would be lower, and the amount of base needed to titrate it would be greater. This is because the pH of a fruit vinegar would be lower, as it is digestible and meant to resemble stomach acid in its properties. This differs from a grain-based vinegar with a higher pH, such as distilled white vinegar, that is commonly used as a cleaning agent, leading to the conclusion that it has a greater acetic acid concentration than that of the fruit vinegars.
In this lab, we used a burette, an Erlenmeyer flask, a 10 milliliter graduated cylinder, a phenolphthalein indicator, a dropper, a burette stand, a burette clamp, distilled water, apple cider vinegar, white vinegar, coconut vinegar, rice vinegar, white wine vinegar, 0.25 molar NaOH, and 1.0 molar NaOH.
You'll notice that the beloved Haven Townsend is no longer with us in this video, unfortunately, because there are no hoes in chemistry. We don't make the rules. Okay, our independent variables is the type of vinegar, which our levels were white vinegar, rice vinegar, apple cider vinegar, white wine vinegar, and malt vinegar. Our dependent variable was the amount of NaOH that it took to titrate the vinegars. And our controlled variables were the amount of vinegar, 10 milliliters for each, the molarity of the NaOH, which was taken out in calculations, and the type of indicator, phenolphthalein.
First, we measured 10 milliliters of NaOH and put it into the Erlenmeyer flask. Then, we put 3 to 4 drops of the indicator into the flask and shook it up to ensure that the indicator was evenly distributed. We then put the flask under the burette and began the experiment. This is what a successful titration looks like. This is what an unsuccessful titration looks like.
The research question was, what is the amount of NaOH needed to titrate, and thus the concentration of acetic acid in different types of vinegar? And the hypothesis was, if the type of vinegar used has a lesser fruit content, then the molar concentration of the acetic acid will be lower, and the amount of base needed to titrate it would be greater. This experiment required the titration of 5 different types of vinegar by slowly adding the NaOH to 10.0 millimeters of the certain vinegar type until a very pale pink color had been achieved. So apple cider vinegar yielded a molar concentration of 0.9036 molar with a percent error of 12.5%. White vinegar yielded a molar concentration of 0.8984 molar with a percent error of 12.5%. Coconut vinegar yielded a molar concentration of 0.2786 molar with a percent error of 25%. White wine vinegar yielded a molar concentration of 0.6648 molar with a percent error of 12.5. Rice vinegar yielded a molar concentration of 0.5558 molar with a percent error of 50%. This data proved our hypothesis correct, where vinegars with a greater fruit content, being apple cider, white wine, and coconut, had a greater molar concentration of acetic acid. This also proves the point that vinegars with a lesser fruit content, i.e. grain-based vinegars, which would have been our distilled white vinegar and the rice vinegar, would have a lower molar concentration of acetic acid. There are, though, some exceptions to this data, and that do not prove our hypothesis. For example, the lowest molar concentration is collected by the coconut vinegar, which should, by our hypothesis, have a greater concentration as it falls under a fruit-based vinegar. There is most likely another factor in the coconut vinegar or the distilled white vinegar, which is also an exception to the data, or to our hypothesis, that causes it to fall under the title of an exception.
I'm with Virginia Democrats, and I support this chemistry project.
I'm Chris.
I'm Bridget.
I'm Veronica.
I'm Haven. And you're watching Disney Channel.
Idiot.
This question is formed around the basis of needing... I lost my place.
Oh no. Behind the scenes. Guess who's doing work? Not Veronica. Guess who's doing work? Not Chris. Comment in this video. Are you ready, Veronica?
Wait till this wind dies down.